Hi there, my name is Ron Rogers, and I'm going to talk about Qantas Flight 32. Now, I had one of my um, followers suggest getting into this accident, and I was basically familiar with it, but until I got into it, this is an amazing accident. This is the type of accident as a flight crew you just don't you just don't want to be involved in. Fortunately, it had a very happy conclusion, but oh, was this thing ever an adventure? This occurred, Qantas Flight 32, on a flight from Singapore to London. So they had a lot of gas, so they had time to work the problem, and boy, did they have a problem to work. And just shortly after takeoff, 4 minutes actually after takeoff, passing through 7,000 feet, they had an issue with their Rolls-Royce Trent 900 engine, and it disintegrated. It's the number two engine. This is a four-engine aircraft, obviously, and this was the number two engine. That's the inboard one on the left side, and it disintegrated, causing extensive damage to the nacelle, wing, fuel system, landing gear, flight control, engine controls, and caused a fire in the fuel tank that self-extinguished. It also caused just a myriad of system problems. And this was the first serious incident with the A380, and this is back in 2010, and it is really the only serious incident they've had, or anything of this magnitude. And delving into this, the Australian Transport Safety Bureau wrote one of the most extensive, detailed, thorough accident report I've ever read. It was a little bit over 300 pages, and they just did an excellent job. It was really impressive to read, and the basic problem all went from a manufacturing error on a stub pipe within the engine. This was a lubrication pipe to lubricate the aft engine intermediate pressure turbine disc, and due to a manufacturing error, they got a fatigue crack, and this failed, causing a fire and caused a disintegration of this disc, and the damage was just amazing, and what they had to go through, and I'll cover that. I think you'll find this very interesting. But first of all, I want to give you a little background of mine regarding Airbus. And I think most of you know that I was chairman of the ALPA National New Aircraft Evaluation and Certification Committee, and got to do test flights on the Airbus 319, 20, 21, 330, and 340, and various variants of that. I was out of the committee by the time the 380 came along, but my vice chairman, Terry Lutz, who took over the committee, was, of course, was very involved with this. In fact, he retired from Northwest and was hired by Airbus as a test pilot, and one of the first flights he got to do was on the Airbus 380, which is very interesting. And it took him almost a year to get all the visas worked out, but Terry had a very enjoyable time working for Airbus in this capacity. And it was kind of funny. Terry, of course, retired from the Air Force and then came over, so he didn't have a lot of seniority, and he calls me on the phone one night. He'd just shot a Cat 2 approach in a DC-9 into Detroit, and they had a lot of deferred systems, and it was really just a pain. And I had just landed in Kona on the 777, going to a very nice layover, so it was kind of like, he was just kind of down, and we were, and I said, well, I'm here in Hawaii, but he did very well getting this job. But they brought the 380, Airbus brought the 380 into Oshkosh in 2009, just a year before this accident. It's kind of funny. I almost didn't realize it was that long ago, but okay. And you may have seen the YouTube video on this, and Terry was quick to point out that Pierre did that landing. Terry said he was just yanking the gear on it. He had nothing to do with that landing, and it was quite an arrival. You can actually see structural modes in the wing, and like I said, there's YouTube on it. It was an amazing arrival. But okay, Terry's in at Oshkosh with the 380, and he's going to give me a little private tour. And okay, we're talking on cell phones, and he says, "Yeah, come on up." They hadn't start the general public tour yet, and he says, "Well, just come on up. I'll get you on and go through before we get all the people on board." So I said, "Okay, fine." So I'm coming on up, and it's got a line. It's raining. It's got a line that goes 3 times around, and so I'm kind of cutting through the line, as it were, going straight to the air stairs there, and I'm getting a lot of dirty looks, unfortunately. And there was a lady at the bottom, one of the volunteers, who her job was to, regulate the people. And I am just getting the look of death from her. Like, who do you think you are? What do you think you're doing? But as I approached it, I'm talking to Terry on the cell phone. I said, Terry, I might need your help here, because this lady doesn't look like she's going to let me get anywhere near the stairs. And Terry came down the stairs a little bit, got her attention, and then the whole event changed. So here we are up in the 380. That's Terry, who had been my vice chairman, and did very well. He actually, for those of you from our Society of Experimental Test Pilots, Terry was very accomplished, but he was basically, because he was an airline pilot now, he was a stuck at associate member. Well, by coming onto the committee and doing the work he did, and especially then following on going to Airbus, he rose to member, associate, fellow, and then finally fellow just a few years ago. So extremely well deserved. It was very great that his career was able to progress at that point, because most of the time the test pilots who come on to be airline pilots, their flight test career a lot of times ends. But a lot of times, what was nice about my committee, I was able to bring on some fantastic talent. In fact, some of the people I had to turn down, I ought to do a thing on that, about the people I brought on, and the people I had to turn down. I turned down because it's a lot of politics, and I only had so many places, and I could only bring so many people on from certain airlines, that I had to turn down people that I just absolutely regretted turning down. But Terry wasn't one of them. He came on soon enough, and we were kind of overloaded with people from United and Northwest, and a person I couldn't bring on was a United person. He actually went back, and he decided he didn't like pulling gear on the 757, and went back and was a F-117 test pilot. So he's had a very nice career. Actually got to be president of Society of Experimental Test Pilots later. So he did all right. But anyway, I digress. So there's me sitting in the 380 cockpit. That's as close as I got to ever flying the 380, but I can talk about it to a certain extent because I'm familiar with Airbus systems and how they operate, and I am absolutely impressed with the architecture on their design. Here's getting the cockpit tour, and this was not something that the general public got to see. They just got to go through the main section of the aircraft, and this was a flight test aircraft, and I'll show you that in a second. Now here we are up in the cockpit, and Terry's demonstrating a lot of the various functions of the aircraft. This wasn't unfortunately open to the public to get in and see, but with the tour, Terry was able to show this to me. And one of the things Terry was working on at the time, one of his programs at Airbus, was a brake to vacate program. And basically what it was you set up, you said, okay, I'm going to land on 27 right, and the second to the last taxiway is Echo 2, and I'm pretty sure that I can be stopped by then, down to taxi speed. So I will put that in the computer here, and then the aircraft will modulate the brakes to give you a nice smooth deceleration, so when you get to Echo 2, you can make the turnoff. Great system, because normally you got to set some auto brake setting, like medium, low, medium, high, max, which you don't want to do if you're doing a normal landing, or on some of it's 1 2 3 auto brakes, 1 2 3, and then basically some point during the landing you see that you're decelerating too quickly, and you have to get on the brakes to release the auto brakes, and that causes a little bit of a lurch, and that's always that's not kind of what you like. So this gives you a nice smooth deceleration, so you can get in a nice turnoff. And one of the other things I want you to notice there is the black and white display. And you see on the lower part of there, that's a picture from a camera that's mounted on the vertical stabilizer looking down. Now, when I flew the 777-300 in flight test, we had nice cameras around that, and I think Airbus was copying that design. And the thing I liked about it was supposedly on the line, you're not supposed to look at it during flight, but it was really cool because it was just beautiful pictures. You could watch the gear come down. You could see the contrails off the engines. You could see a lot. But the thing I liked on the ground, especially in the flight test environment where it wasn't really kind of a normal environment, but I think would be useful in airline flying, is you could see that everybody was away from the aircraft. So you weren't going to run over anybody, which was nice when you started to taxi. So I think that was a very nice aspect of it. Now, after I got a very nice cockpit tour there, Terry took me out into the back of the aircraft. And you see those tanks there. That's for ballast. You move water back and forth to change the CG, and you can actually use it, obviously, to increase the weight and stuff like that. We always joked that, it's Airbus, so those tanks are full of wine instead of water like everybody else used. So I joked to Terry about that. I said, well, you probably brought a lot of wine over from France because they flew from Toulouse over to Oshkosh. And he says, well, actually, right back in this area, we do have a little bit of a few little cases of wine there that are going to keep us in pretty good stead for just a while. But again, this was a flight test aircraft, so it had the flight test station, and typically, there's only about like 6 or 10 seats in the aircraft for the flight test engineers. And I always joked with Boeing and Airbus. I said, man, if you want to make money, you're going to have to put a few more seats on this thing. Okay, well, enough of Oshkosh and the 380. Let's get back to this whole accident scenario. Here is a picture of the Rolls-Royce Trent 900 engine, and when the disc separated in the back there, of course, it threw out a lot of parts, and I'll show you that trajectory in a second. And it also, of course, tore away the cowling. The cowling is gone there. This is what the cowling looks like when it's open for normal inspection of the engine. And this is a Trent engine that has not had any issues to damage the cowling. All right, here is what happened when that rotor section came apart. It threw debris through the left wing, leading edge, and the front spar. Shot a piece onto the ground, and one section went through the belly fairing. There were probably a few more sections that went various other places, but these were the main pieces that digressed from the aircraft. Now this is a picture of the forward instrument panel. There you see the engine warning display. That's just your basic engine instruments. And below that is the ECAM display. Now ECAM stands for Electronic Centralized Aircraft Monitoring. And that is basically when something goes wrong, your checklist will pop up. Now their initial indication, now this happened at 7,000 feet. The captain immediately leveled the aircraft. He went into altitude hold, and he expected that the auto thrust system would limit the speed to 250 below 10, and it didn't. That was one of the first indications that they had degraded issues, and they had a lot of degraded issues. Well, they had initially an overheat warning on the number 2 engine, which changed to fire. And part of the procedure on the overheat is you pull the throttle back, and then it went to a fire indication. So they went through the procedure, which involves discharging the fire bottle. Interesting, you'll see why they had some of these problems when I show you the damage that it did to the wiring bundles. It's amazing. But they didn't get a discharge light, no indication that the bottle had actually discharged. So they followed the procedure. 30 seconds later, you discharge the second bottle. They did that, and they didn't get an indication that one had discharged. Now, they started to get the ECAM warnings, and inoperative messages were coming up. And Airbus determined that all of these were valid. These weren't any false any false warnings or misconstrued system problems. They started to get just a plethora of warnings. And here's a little depiction, and I'm just going to cover the initial part because this just went on through the entire flight. They went into a holding pattern. They spent over 50 minutes just working the checklist. I would not want to do this in a simulator on the ground. I would think that the instructor is being totally unfair, giving me all these emergencies. And these guys had to go through the checklist. They were all valid. It took a long time. Fortunately, they had the fuel because they were going on a long flight, and they had a captain, first officer, second officer, and two very experienced check airmen on board. So the captain had plenty of help on this whole thing. But okay, here are the messages they're getting. They got messages that engines 1 and 4 were operating in a degraded mode. The green hydraulic system, which is on the left side, and Airbus does hydraulic systems by colors. And the green was on the left side. They were getting low system pressure and low fluid level. The yellow hydraulic system, also with issues. Engine number 4 pump errors. Failure of the AC electrical number 1 and 2 buses. Flight control operating in alternate law. And we'll talk about some of the degraded flight control laws in this as they're coming in on approach, because that was quite interesting. And all the issues with the flight control laws were appropriate, and the degradations due to system failures were appropriate. There was nothing that the airplane did wrong in this. It was the engine that was the culprit. Okay, so they had the flight controls operating in alternate law. The wing slats were inoperative. The flight controls, ailerons, partial control only. They had reduced boiler control. The landing gear control and indicator warning systems had errors. Multiple fuel system messages, including a fuel jettison fault. So normally they would want to jettison fuel to come in and land. Once they had gone through all the procedures and everything was fine and stuff like that. But they had a problem with that system. They got center of gravity messages, auto thrust and auto land inoperative. The number 1 engine generator drive disconnected. See, this is number 2, but now they're getting issues with number 1. Left wing pneumatic bleed and avionics systems overheat. So they had their hands full. And here is a picture that one of the passengers took from the wing there, and those are holes that went through the leading edge, and one went and damaged actually the spar. And there is a picture of the fuel leak that was initially seen by one of the pilot passengers on the video display, and the second officer went to the window area there, and passenger got a picture of the fuel that was being vented. And they initially had a fire in that fuel tank, but fortunately it went out on its own. So here is, shortly after takeoff, there's the flight path, a fairly large debris field. And there is, it shows you where the engine event was after takeoff out of Singapore. And I've flown into Singapore a lot. Very, very nice, enjoyable layover. Just don't spit on the roadway there. You'll get into a lot of trouble. You can really raise Cain. I digress. Anyway, they had the engine event, and they went into the holding pattern to handle the situation. And there is a picture of the, you can almost see through the engine there. The disc really tore things out. And there's another picture, and when they had fire in the engine. And one more picture. And there you can see the burnt thrust reverser. And they had localizer burning in the thrust reverser structure. Now, this is what's interesting. Look at that the shrapnel from the engine just tore through that complete wire bundle. And these are electric and electronic airplanes, so having a wiring bundle severed like that caused a lot of problems. And there's another wiring bundle that took a hit, and there are holes through the wing there. Now, due to the loss of the green system and damage to the yellow system, there were a lot of flight controls that were left inoperative. Of course, they on an aircraft like this, you have multiple backups, and those were able to still allow aircraft control, degraded but reasonable aircraft control. All right, so here's my electrical engineering part coming through. I just love the architecture of this system. These modern aircraft, I joked with Boeing on the 777 on some of their emergency buses. I said, about the only thing I don't see on the emergency bus is the coffee maker. You've just got everything on there. So even if you're down to extreme loss of power, you still got a lot of functioning things. And look at this, they've got two batteries. They've got battery 1, battery 2. They got an essential battery, and I'm not even counting the APU battery for starting the APU. They've got 4 engine-driven generators, and they've got the APU generator. They even got a ram air turbine generator, so you're going to get electrical power. And they've got 4 external power ports. Now, you're probably wondering, why 4 external power ports? My gosh. Well, typically when you're on the ground, you're getting ready to leave. You want to get the ovens up to speed, because on these long flights like this, what you like to do is you get the meals cooked, you get the service out there right away, because these people have been, traveling to the airport, hanging around, they're hungry. So you get them fed, you get them a little boozed up, and then they're quiet so the flight attendants can rest for the next several hours. If you've flown long international, you've seen how that functions. But now, let's talk about their situation here. The AC power generation feed lines from generator 1 and 2 were severed by the engine debris, removing the power supply to AC bus bar 1 and AC bus 2. Now, the system automatically reconfigured AC bus 1 to obtain its supply from AC bus 4. When the crew started the APU, AC bus 1 was reconfigured to be supplied with AC power from the APU generator A. Now, in the event of loss of power to AC bus 2, the system would normally reconfigure to receive a supply from AC bus 3. But due to residual current being sensed from the number 2 generator, engine generator, the generator and ground power control unit considered the number 2 generator was still online and isolated AC bus 2. So that's probably not how you want to sense that. This resulted in AC bus 2 being unable to reconfigure, and it was not powered. Now, the loss of AC bus 2 resulted in the loss of the air data inertial reference unit, ADIRU number 3, and one of ADIRU number 3's function is to provide a speed signal to the electric power system. Now, this speed signal is used by the electric power system to determine which APU generators are available to supply power. When the power was lost to ADIRU3, its speed signal output was frozen, and the speed higher than 50 knots configuration, where it was frozen, said, okay, you're in the air mode, and this caused problems. Once they landed, they lost a lot of power, and they only had one VHF radio to talk to the ground people, and they were a little actually confused over which radio even was operating. All the screens went blank, and just before they went blank, they had one indication of high brake temperature over 900 degrees C, so that's not good. So, when the electrical system was locked in the air mode, only APU generator A was available to supply power following the shutdowns of engine 3 and 4. This resulted in only AC bus 1 and the essential bus bar continuing to supply with AC power. That's why they lost all but one flight deck screen. So they had quite a few issues with the electrical system once they got on the ground, and unfortunately it caused a little problem in communication, but the crew handled it quite well. And here basically is what they had. essentially they had elevator and rudder power, and they had spoilers and flaps, but they did not have the leading edge devices. Now, this is where it really gets kind of interesting, because okay, they're trying to compute um, a landing distance. All right, and you have the onboard system, and Airbus has a system where you can do this on laptops and that. But in trying to determine the landing distance, they had all sorts of inoperative situations. They didn't have the leading edge devices. They had various systems that were non-functioning, that were important to determine the landing distance, and basically they had quite a bit of trouble determining the landing performance. And they finally were able to do a calculation, and normally they would want to dump fuel, but they landed, I think it was 41 tons over maximum landing weight. Which is fine. The aircraft are totally capable of that, but they weren't able to really. They had a lot of trouble getting an accurate landing distance. Finally, they got one that says, "Hey, you can stop within about 300 feet from the end of the runway," which they did. But and that was also kind of interesting in this whole system. They did stop on the runway and safely, and the information was accurate. Now, coming in on final, the captain had a lot of interesting issues. Now, like I said, leading up to the landing calculation, oh, by the way, the ACAR system, which is an automatic reporting system, was sending to the company, and all the large aircraft do this. I was on the 777 one time on a flight, and I got a call from maintenance saying, "We're watching the engine oil level in, I think it was the number 2 engine." They said, "We notice it decreasing at a little higher rate than we'd like. We're going to keep an eye on it." Well, that was kind of news to me. I hadn't noticed anything, and it didn't seem like a significant change to me, but they were monitoring it. So people are watching out for your system's operations. And in this process, the company called them up and says, "We show you've got a few problems there." And the crew was just a bit busy handling that. But now, okay, calculating the landing distance. Now, they had inoperative wing leading edge lift devices. They had reduced brake function, reduced number of operational spoilers, an inactive left engine thrust reverser, and this abnormal configuration caused a lot of problems trying to calculate this distance. But like I said, they were able to finally determine it, and they did a few controllability checks coming in just to make sure. The crew wasn't quite sure of the total extent of the damage, obviously. So they did a few controllability checks, and as the captain came in on final, they asked for a nice long 20-mile final, and they got a one coming into runway 20 center there at Singapore. And as they progressively configured the aircraft, they conducted further controllability checks to make sure that everything was fine. Basically, to fly the airplane, the captain set engines 1 and 4 to provide symmetrical thrust, and then basically control the aircraft speed with the thrust on engine 3, which I think is an interesting technique. Like I said, he disconnected to do these checks and re-engage it, but the autopilot twice disconnected through the approach, and they were automatic disconnects in response to the autopilot system detecting issues, and some of these were with angle of attack, and it disconnected once. He reconnected it, and it disconnected a second time, comes through 800 feet. So he says, "Hey, I'm just going to leave it off and fly through there." I would have had a tendency to hand fly the aircraft more, but that's a little different situation. And then getting on the ground was quite interesting. Now, they tried to shut the engines off, and they shut them all off, except the number 1 engine would not shut off. and they tried the fire handle, they tried recycling the fuel selector there, and it just wouldn't go. And one of the interesting aspects of it, okay, they're leaking fuel out of the wing. They've got an engine that won't shut down. Just before they shut down, and the aircraft did not properly reconfigure to the electrical ground mode because there was a sensor saying, nope, you're still flying. They saw a landing gear brake temperature at 900 degrees C and rising. Now, I think even if you fly Cessna 150s, you know that's a little bit on the hot side. Okay, so they were a little concerned. They tried everything they could do to shut it down. When you have a large aircraft like this, and you have an evacuation, it's a pretty much given that people are going to get hurt in the evacuation, especially as high as some of these slides are, and it's a pretty good trip down that slide. So the captain elected to keep flight attendants next to the doors and just use the right side. Basically, and exit out of one door. And instead of going down a slide, he got the air stairs. It was about 50 minutes after they had landed before they got the air stairs out there, but they had a very orderly exit of the passengers and nobody was injured, which is very good. Of course, this was a situation with leaking fuel, hot brakes, an engine that wouldn't shut down. It could have turned bad very quickly. I don't know if I'd had more of a tendency to evacuate or not, but the captain did make a very good decision here, and nobody was hurt. So you can't judge that badly. One of the interesting things, though, was they could not shut down this engine, so they essentially drowned the engine. This engine, they didn't get the engine shut down till 3 hours after the aircraft had landed. Now, that's kind of interesting. When I was out at Edwards, we had some helicopters for the Army. They were doing testing of the minimum they were doing the auto rotation envelope, and there's a point where you're at a minimum altitude and airspeed, and that you can't successfully auto rotate. And they, of course, approached this cautiously like they did, but they went one step too far, the Army helicopter test pilots, and they found a altitude and speed configuration where you could not successfully transition to auto rotation, and they did not. The helicopter impacted the ground, the rotor blades came down, chopped the tail off, and the rotor blades disintegrated. The crew exited the aircraft, but they didn't shut down the engine, which of course was running at 100%. I don't know why they couldn't re-engage it, and attempt to save it, but anyway, they crashed. And the fire department sat there and they tried to extinguish that engine on the helicopter, and they had special stuff on the front of the engine that was supposed to protect it from foreign object damage, and I guess it diffused the water, and they poured a ton of water in that engine. I was working at the command post at the time, and they had a heck of a time drowning the engine to get it shut down, but apparently these guys were able to do it successfully. So basically, this is a type of accident, incident, emergency that I do not wish on anybody. You talk about a myriad of checklists, and they had approximately 100 checklists to go through, and it took them 50 minutes to do this. And the nice thing about the electronic checklist is when you do the item, it configures it and it continues on. So that's better than like we had on the 27 with the paper checklist where you had to have bookmarks and you went back and forth between them. And I joked with my instructors that you needed a lost in checklist procedure because sometimes you could. But at least this keeps it very organized and keeps the flow very nice. So I hope you found that interesting. It was, to me, just an amazing incident. And one thing I wanted, I missed covering here. They had a number of activations of the protections coming in. The first two were low energy alerts, and I guess these were valid due to now it was sensing angle of attack, which is valid, of course, for the configuration as it senses. And the captain did what you do when you get a low energy type of warning: you advance power, and that solved it. The final one, I think, is they had the first one at about 1,000 feet. They had a second one at 362 feet, and finally, essentially in the flare, it was at a radio altitude of 3 feet. They got a stall warning. Well, okay. I can handle that. You bring the aircraft in. Normally we go, you tell somebody how to land. Says you bring it down within half an inch and then you just let it drop. Well, 3 feet getting a stall warning, they could pretty much, the gear could handle that. But part of the whole deal, because they had damage to the systems, the loss of the leading edge slats, the aircraft control system reverted from normal to alternate law, and the ECAM messages told the crew that they had lost a lot of envelope protections. The only protection they lost was alpha floor, and under alternate law, they still had the stall warning systems. And during the investigation, Airbus did conclude that all of these were valid. So, like I said, this is one of the most detailed, complete accident investigation reports I have ever read. The Australians really did a good job on this, and this is the type of event that, as an airline pilot, you really don't want to be subject to. Absolutely multiple serious emergencies. So that was quite an incident. Nobody was injured. It came out very well. And it speaks a lot to the quality the quality of systems design and the engineering on this aircraft. And of course, the unfortunate thing is that the 380 has been somewhat of a I don't want to say disaster financially, but it has not worked out well, and they're parking aircraft that have not even come close to, of course, their service life. And I guess they are having some wing cracking issues and stuff like that. Seems that seems to be an issue on large aircraft. There's a lot of large aircraft that have wing cracking issues. Anyway, I hope you enjoyed it and found it interesting. Thanks for watching.